Okay, might have some audio here. Perfect. So let's see what else we're doing here. Let's get rid of that. We are live. And get rid of this background. Okay, nice. So it kind of works. Sweet. So feel free to leave suggestions and comments on this, guys. So we will be winging this completely. So I don't really have that much background information, and we don't really have time to put like 2-3 hours, something like that. We don't really have enough time to do that. So we're just going to do like a live stream basically. So just viewing, going through stuff, some comments and thoughts, and seeing how it goes. Really, like, can we like fit all of this into 15-20 minutes, something like that, so that it works as a standalone video also. And this is potentially beneficial to do this as a live stream, because then we can get comments from you guys and see how that goes. So it might be beneficial for that. So let's just refresh this YouTube here so we can get the comment things going here. Okay, nice. So we are hopefully still up here. Yeah, okay, got the comment section loaded in here. So yeah, feel free to leave comments and suggestions on this. So we recently ran a poll on our YouTube stream. Let's actually pull that up quickly here on our racing YouTube. Let's check this out. So this is a separate account I'm viewing this on. Yes, we are live. Nice. Wait, community, I think it's in here. Yeah, so we ran this, comments on this. So yeah, Ville Kinnunen suggested us to check out thoughts on rotary valves, so specifically about the cylinder head rotary valves. And this was actually a really good question, and something to look out or do some really quick analysis on and thoughts on to begin with. And that's basically why we're here at the moment, guys. So if you're viewing this in the future, feel free to leave comments and stuff on that. So mistakes I've made, if we've missed some stuff, if there's been some new developments or something like that. So definitely leave comments on that. Also leave suggestions for future topics. Very much interesting things going on. I mean, there are probably like 20, 30, 40 potential topics that we could do this sort of really quick tech analysis on in the future. So definitely leave comments and suggestions, and see like what topics you would prefer in relation to other topics, so we can maybe do those a little bit earlier in the line, or we'll see what kind of sort of feedback we get, and how sort of useful this maybe is to people to decide on if we do future episodes or not. But what else is there to do? So, and of course, because we are live streaming, so the whole point of live streaming is to be able to respond to comments. So if you have like questions, or I make remarks or something that leave like things too much open or something like that, then feel free to leave comments. I will try to check those out during the stream and reply to those as much as possible. And this will probably like help other people also viewing this in the future, or other concurrent viewers. So that should really help out, and because it's really difficult to live explain things like compact, but also not like leaving out important things. So if there are things that are important that I maybe missed or something, then please put that in the comments, and we'll get back to that. So yeah, let's just start out with seeing if we can get some pictures maybe here. Rotary valve cylinder head. So there are a few different types of rotary valves that I do want to discuss. Okay, so this is one of them. Well, we can just, well, actually I want to probably start from do we have disc type valves? I think those have been used before these, like drum type rotary valves for cylinder head use specifically. Yeah. Okay, that might be a little bit difficult. Yeah, I haven't really found that. Okay, but I can start with checking rotary valves. So valve 2-stroke. So these are like disc type valves. Is this large enough? Let's see. Can we zoom this? Oh no, it doesn't. Come on, you can do it. Okay, so if we view the file, can we then zoom it? Okay, nice. So this should be visible. Ooh, yikes. I'm not. Okay, yeah, this should work absolutely fine. So yeah, this is a disc type rotary valve, which I have seen some use for, like cylinder head options also, and so like similar to this have been used as throttle body options also on 4-stroke engines. So these are like typically used for crankcase ventilated 2-stroke engines, because you have a low pressure differential, so you don't really need, so there aren't like, so in like this how should I explain this with, oh, this is kind of difficult, but yeah, so in the plane sort of in the view direction on the screen, to have like pressure differences in that direction will of course create friction between this disc. So this disc spins around, and that is linked to the, either direct to the crankcase or via like a belt pulley or something like that to the crankcase, and rotates at the crankcase speed basically. And this is, yeah, when this type of a valve is open, it has very, very good CD value, so you don't really have a lot of drag on that, and mass is very low, very quick to accelerate, but the sort of I should say sort of a friction losses when you start increasing the pressure difference starts getting complicated with this type of a valve. So that's why I'm assuming that it's not being used that much on sort of more modern 4-stroke engines anymore. Can I go back? No. So yeah, these are like initial. Yeah, these can of course be used for a 4-stroke engine. Also, you just have this in place of a poppet valve. And yeah, you can run this as long as you don't have high pressure differences. So like in really old engines, for instance, where you don't have the material strength or the sealing strength or stuff like this, or the fuel anti-knock capabilities or fuel pump pressure for compression ignited engines. So then you might be able to run these types of valves, but that's not what we're looking at the moment, but just to give some kind of a wait, can we actually go back here? Oh yeah, we can. Nice. Okay, so so we want to look at these type of valves, but let's get a drawing going here first. I think there was a good one down here somewhere. Okay, so this has okay, yeah, so this has refreshed and is slightly different now. I guess we could open it this. Okay, so let's just view this. So yeah, these are sort of drum type rotary valves, and this is so okay. You should be able to see most of this. Oh, the cursor is really small. Okay, I need to figure that out for the next potential stream. But anyway, so on the left here, yeah, basically have a induction stroke. So the intake drum there on the left is sort of rotating into the open area. So you have a duct through the drum basically that goes into the cylinder directly. So the benefit with this is, of course, you don't have reciprocating parts like poppet valves that in most cases will be the limiting factor to how much RPM you can run from an engine. With this type of a drum thing is just spinning, so you can run at very, very high RPM. It does have much more inertia though typically, so sort of throttle response is maybe a bad term, but yeah, the engine overall rotating inertia will be higher with this drum type valve train system, definitely, because yeah, camshafts and stuff like this, they are really small diameter. Yeah, valve train or poppet valve train components are mass optimized and really compact. So not a huge sort of yeah, inertia wise. So yeah, inertia wise, these drum type rotary valves definitely worse than poppet valves. Let's go back and oh wait. Okay, so let's check out one of these more modern type drum valves. So let me explain what these look like. So as far as I know, there are like two different types of rotary valves. Okay, yeah, so you can. So this is one type of these. Let's just zoom this. So can we scroll down? Oh, we can. Yeah. Okay, so with this type of a rotary valve, you just have a single opening at the cylinder head. So this potentially allows for really, really large sort of a valve flow to cylinder diameter ratios. So this potentially allows to run like sort of long stroke, small bore setups that theoretically have a very good sort of combustion chamber volume to a surface area ratio. Because yeah, if you have a smaller diameter combustion chamber, so with the same compression ratio, it's more round basically, and the closer to a round shape you can get, the lower amount of surface area you have for a given amount of volume. And this slightly increases your efficiency, so you don't transfer as much combustion heat into the cylinder head and the piston and into the cooling system of the engine, basically. So this increases your efficiency a little bit, and that is, of course, yeah, always beneficial. So that is the plus side of this. The bottom side, or the sort of drawback for this type of a system, is that valve overlap period is kind of yikes. So having like this type of a port, intake and exhaust port open, of course you probably would need to optimize this much more to bring that port much closer to the cylinder head. But oh yeah, and in case yeah, I didn't explain this really good to start with. So with this type of a single port thing, so you have a rotary port that rotates around, and in one position it's open to the inlet side, and then when it rotates further, it closes, of course, and then you have the compression stroke and power stroke, and then it opens to the exhaust side, and you basically have the same port that is open to the exhaust or the intake side. So you basically have like can almost use like the full diameter for intake port or exhaust port. So that's a huge benefit, but valve overlap is kind of yikes. I'm not really sure you could maybe be able to get away with that, but yeah, not really sure how well that works. And potentially, depending on how you have those ductings designed, you might be able to cool the rotor from the intake charge a little bit, which kind of is not ideal, but yeah, you definitely want to keep thermal expansion ratios. Those are yeah, one potential problem with these type of valves. So then we have the other type of these drum type. Okay, I think this is actually quite a good picture. Okay, this is actually a really good comparison here. So let's zoom in this. So yeah, here we have a poppet valve type here to the right. Well, you can barely see my mouse cursor. Okay, but yeah, so you have the intake side and exhaust side, and this is a double drum type rotary valve system. So you just replace the intake valve with one drum and the exhaust valve with one drum. So here you don't really gain, well, you do gain some potential surface area, but also there is, yeah, you do also increase the sort of complexity here of the sort of combustion chamber shape. And again, all these sort of small, like these corners here. Let's zoom in even further. Okay, this is max zoom in. So I'm not sure how well you can see this. Can I? Oh no. Well, like this area here with this icon that I'm dragging here now. Oh, you can see the icon. It doesn't. Oh, that doesn't show up on these. Okay. Interesting. But anyway, so these small corners here where the drum, because the drum surface is round and the combustion chamber is like round but in the opposite direction, so you end up with these small like interior corners, and those are really bad for like complete combustion and emissions purposes, and probably not really ideal for knock use either. They're not super critical. It's more like the sort of protruding sharp edges that are more critical for knock typically, but yeah, this is sort of, yeah, the other option in relation to having just a single big drum that bends to both sides. So again, the upside is potentially higher RPM, or well, not potentially, I mean you can run these rotary valves at like any RPM basically until you start reaching sort of inertia sort of limits on that, so that you will be limited to like turbocharger like RPM or something like that. So you could run those probably at maybe 50,000 RPM or something like that before you start having like major structure issues with these type of drum valves. And these of course need to run. So yeah, these need to run at half the RPM of the crankshaft. So you could potentially have a crankshaft running at 100,000 RPM and these running at 50,000 RPM. Of course, it's not really possible to transfer the gases in that high of a speed. So it's maybe not really that beneficial. But yeah. But okay, I think these are the basics at least. Feel free to comment. Four-stroke torpedo engines. Ah, okay. So there were actually some disc type rotary valves. Okay, so excellent. I wasn't just talking out of my ass. So yeah, John Newman there commenting on that. There was World War II four-stroke German torpedo engines. The Junkers Umo KV-8 apparently. So yeah, I mean the Junkers did a lot of good stuff there. So they had the opposing piston, opposed piston. I think that was the Junkers Umo 204 engine that they used in aircraft use. So with yeah, insanely high efficiencies. I mean way back in the 1940s. So probably designed that already in the 1930s or something. So yeah, really interesting company that was really sort of advanced at the time. I have absolutely no clue what happened with them, but have you seen that E36 BMW with a single drum valve? I haven't actually seen that myself, but I'm assuming it's similar to this type of a system. So I just have a single inlet port that alternates between connecting to the exhaust and the inlet. Ah, okay, yeah, Wankel related stuff. Okay, yeah, I mean definitely, yeah, I think that there are some relations to Wankel engines, but of course, Wankel engines have the problem. Yeah, I mean, the Wankel sort of taco or disc or whatever that is actually called, It doesn't well, it also rotates, but it doesn't rotate around the central axle, so it moves around, and that rotor disc is really heavy. So you have some really high sort of inertial loads when you rev those engines higher, so that's why Wankel engines don't really rev very high. Of course, it depends, of course, what you compare to. So if you compare to typical street engines or something like that, then of course, yeah, a Wankel engine will be able to easily rev higher than 8,000, 9,000 RPM or something like that. But then when you start getting to really high-strung racing engines that go to 20,000 plus RPM, then I'm not really sure. I haven't analyzed Wankel engines that much, but I would assume that you start getting into huge efficiency and sort of bearing loading sort of losses with running Wankel engines at really high RPM. So yeah, but of course, having a rotor on the valve section instead, so this just rotates around the central axis. So then you don't have those type of problems at all. So that's the big benefit of running these types of valves. So coefficient, so valve flow potential, that's kind of tough, really. You can get really good coefficient of drag values with poppet valves, and they're not really so yeah, these valves over here to the right. So I don't really see there being a huge flow potential gain with these rotary drum type valves, but in certain circumstances there might be. I mean, you might be able to run smaller bore for the sort of corresponding RPM. But yeah, you do have, for emission purposes and durability stuff, is a big question mark, in my opinion. So, I mean, of course, people have been able to engineer Wankel engines to run also, which run at really high temperatures, have the combustion section continuously at really high temperature. Of course, the seals rotate out into the cool section, so that really helps with temperatures. Otherwise they would pretty much be jet engine stuff, so you need insane ceramic stuff to be able to run very high temperatures, or specially designed super alloys and something like that. So yeah, the exhaust section, well, you will need to cool it to the housing or run internal cooling through it for a really high specific power outputs. I'm assuming this is probably doable because I have seen these prototypes running and stuff like this, but there probably is some significant drawbacks with that, potential oil consumption, and then having this combustion chamber shape being not as optimal as poppet valves. And I think that is actually really significant from a sort of a knock limit and sort of fuel efficiency and emissions point. So I don't think we're going to be seeing these sort of rotary drum type valves in production engines. I don't think so, because you will have significant sort of emissions and potential fuel efficiency drawbacks compared to poppet valves. For racing use, that's a little bit of a different question there, because for racing use, so that means well, it depends again on the rules, of course, but by racing use I mean a higher RPM use, so you need to run stiffer valve springs, and that significantly, and you have huge inertia things to take into consideration in the valve train. So with poppet valves, that starts increasing your valve train losses quite significantly. So then you might actually be able to reduce your parasitical losses by running these drum type valve systems significantly, but it's still a little bit iffy. So you probably need to be running up to 15,000, 20,000 RPM, something like that, before you start having these really significant values. For instance, on our Rex engine, we did some analysis on the valve train, sort of, well, some, I mean, study-based and numerical analysis on the valve train component, sort of friction losses. and so by really optimizing those, you might be able to gain like something. So on the RX engine, so running in the sort of 600 horsepower power range with the 45 millimeter inlet air restrictor, that is mandatory for rallycross use. So with that type of a power engine, you could potentially save around sort of 5 to 10 horsepower maybe by really optimizing your valve train. And this is at sort of 7,000, 8,000 RPM range. So yeah, with these drum type things, you can probably reduce the sort of parasitic losses very close to zero, but that will still like only potentially gain you, yeah, probably like a maximum of 10 horsepower or something like that, which I mean in certain race categories can of course be very significant. But yeah, I still think you would really need higher RPM for it to make sense to run those from a sort of a friction loss standpoint. So yeah, I think that's, let's just check this quickly, the chat. So Kefrers, great work as always. Okay, thanks for the comment. Very nice. So yeah, this is basically the analysis, and we are closing up on 30 minutes here. I'm not sure how much of this is actual live and how much is like the pre-roll-in or something like that. But yeah, I think this is pretty much gone through the sort of initial thoughts and stuff like this. So to go through potential fuel efficiency variations. So yeah, both friction losses, emissions view, knock limit stuff. We did touch, well, yeah, I could dive a little bit more into the knock area actually. So yeah, we both have the so from emission standpoint, when you have these like internal like angles, those like so the like gas temperature in those like surface interior like angles have a much lower gas temperature, and you get incomplete combustion, and you get sort of a buildup of carbon deposits and unburnt like fuel and stuff like this, which isn't that super critical for combustion or for knock typically. But then with this type of system, you do have these like interior edges. You can probably blend those in, but yeah, especially with the exhaust roll, I think you will be seeing some reasonably high temperatures. But in relation to poppet valve, I'm going to have to say, on sort of a knock point of view, I think they would be pretty equal, or like a drum type rotary valve might even have a slight advantage there. But yeah, sort of a mass standpoint, it's going to have higher inertia, or this this drum type is going to have higher inertia, worse fuel economy at lower RPM, potentially slightly higher at very high RPM. Emissions are going to be definitely worse emissions, no question about that, I think. And yeah, production cost is maybe something to take into consideration also, and engineering difficulties. So engineering difficulty, I think, is everything is a question about sealing this and maybe manufacturing of the actual drums, which I'm assuming is going to be more difficult than poppet valves, even though I mean poppet valves do have their own difficulties, which are not trivial at all. But I mean, they're solvable, but they take like effort to sort of make work. So yeah, I'm thinking production cost wise and technical wise, probably the poppet valves have the benefit in that regard now also. Yeah. Okay, but I think that is basically it for this episode. So it has been a little bit sort of a wibbly wobbly and trying to figure out how to go through everything, but this is also meant to be sort of, we did select this topic beforehand, so it could easily have cheated a little bit and done some list on stuff to go through, but I wanted to keep this as much sort of a real life stuff as possible, so that it will like represent what this could be like in the future with other topics. Can you have a look at the PatRoVa design? The design made some really bold claims about the wear of his valve. Okay. I'm assuming you can probably make these so that the wear will not be that big of an issue, because I mean, initially looking at these, I think that I would think that these are actually like reasonably difficult to make, but when you compare it to like a Wankel engine, that is much more difficult than this, and people have been able to solve the Wankel engine sort of reliability, I mean, okay enough. So I wouldn't be super sort of surprised if I mean this is a solvable solution, but let's check that quickly. So yeah, PatRoVa. PatRoVa Rotary Valve. Oops. Come on. Oh, let's see. Do we have any like web page? Okay, we do. Okay, let's inspect this. So is this a disk? Okay, so this looks like a disk type valve. Okay, so this looks like it's really closely related to a Wankel type engine. So it has this like axial type sealing force instead of this radial type. I'm not actually sure which is easier to seal. Okay, so this is so this is basically like a single port, so this isn't just like a cutoff with only showing one section, but this is so this is again like basically a single drum, but running like with a sort of a disk type solution, but with a single opening instead of one for the exhaust and one for the intake. Okay, so yeah, you can potentially well, I mean, specifically this geometry is absolutely horrible, but of course this is just like to present the basics of this really. So I think this is actually, it does seem kind of interesting, because you of course want to have this axis running like, so you have the cylinder in this direction, you want to have the rotary axis in this direction, so you can't have the disc like moving over the cylinder. Then you just need to figure out how to place your cylinders. You could probably run like an inline engine with having like alternating sides for the discs or something. You would need to have some like really high-tech drive for that, but you could probably make that work. So that could potentially reduce this this volume here, or you might be able to like do some 3D shaping on this, so you could still run the axis in this like perpendicular to the parallel to the crankshaft axis. That could definitely be doable. But yeah, I mean, having these single type ports where you have both the exhaust and the intake on the same port, I mean, it does provide, I mean, definitely some benefits, because with a poppet valve on the exhaust port, so you only have heating on that from the exhaust gases all the time. So that kind of creates cooling issues. So with this, that might actually have a small benefit, because the incoming air charge cools that sort of those port edges a little bit, or well, not a little bit, but actually quite significantly. So it might like have some durability benefits. Of course, you still have the exhaust section that still stays like fully in the exhaust part there, but yeah, this is definitely interesting. Friction wise, sealing wise, probably doable. So here you have like a significant width also. I mean, inertia wise, this is probably, well, you could maybe run this from a magnesium alloy or something, so you could potentially get this relatively lightweight. I think the exhaust section is a little bit of a question mark, but you could run some good coating on that, and potentially some like internal oil cooling passages in that rotary valve to be able to run that with a relatively light alloy. So you might actually not like end up with a super heavy port. And yeah, you can have overlap periods with these single opening things. Of course, with these type of things, well, how would you do like a variable valve timing? Because that is yeah, if you want a small engine with high horsepower and really good fuel economy, then you really want a variable valve timing. So that is a problem with this type of a solution. Could you you could like do a unevenly rotating shaft that you like offset that so that it doesn't rotate exactly in so yeah, so you can like do this offset type thing where you run what is it, so like these are mechanisms where you have a variable valve duration with poppet valves. So you can run a similar type setup to basically get a variable valve timing with this type of solution also. So you just vary the speed of this disc valve like within the cycle, so to say. You could probably do that, so you could get variable valve timing. You might be able to run this at a relatively low inertia, but yeah, at higher RPM trying to run a variable valve timing with this type of a system, yikes, that could put some serious forces through that variable valve timing system. Size-wise, this might actually be more compact than a poppet valve, because yeah, those end up being really high. But then again, this disc does need to be relatively large also. So size-wise, it might actually be relatively similar to poppet valves. Yeah, this definitely needs some 3D shaping. This just looks funny. Yeah, I mean, you don't need a proof of concept, of course. This can be made to work. Okay, so yeah, here's a little bit more advanced system with sealing stuff. Yeah, I mean, I think that it shouldn't really be any huge problem to seal this. I mean, people have been able to solve sealing a Wankel engine. So I mean, a disc type system like this that yeah, shares the port, so you get the cooling effect from the inlet flow on that also. So that really helps with stuff. So I don't really see there being a big problem sealing this type of engine. I think it should be pretty much, well, easy is maybe a little bit of a yeah, overstatement maybe, but yeah, definitely doable, and nothing that yeah, requires any like big science breakthroughs or anything like that. I think that's basically just relatively yeah, straightforward engineering tasks. So no, definitely very interesting. So yeah, thanks for that yeah, pointer there, John Newman. Very interesting stuff. Okay, so this is like, yeah, combination of a disc and a rotary valve with using a single port type setup. Okay, interesting stuff. So good, that was definitely some more stuff to cover then. Easily added a solid 10 minutes here, but I think this was, yeah, definitely some really high quality stuff to look at these. So I mean, yeah, there are like so many different types of engine innovations and stuff like this. So yeah, interesting to look at sort of one of these things in sort of more detailed stuff. You might be able to, well, yeah, that valve does open in that direction, so yeah, I don't think that will like produce any kind of significant like power losses due to pressure on the valve opening there, so it should be relatively free spinning. And yeah, then you have the sealing, of course, but yeah, I don't really see that as being a big problem, considering you should be able to keep the temperature different, or the temperature sort of relatively consistent. So as long as you can like so with sealing, as long as you can like maintain a gap so that it stays relatively constant, then it's really easy to seal. Then if you have like a sealing that at different temperatures and different loading starts to like deform or something, then the sealing gets really, really difficult, because you need to have like a really robust seal. So it needs to have like a large flexibility to be able to like cope with the changes, but it also needs to like take, and then if it also needs to take heat and stuff, then that gets really difficult. So this type of a system, I think it shouldn't be too difficult to seal this. And yeah, if they are claiming like really good durability on the seals or the system, I mean, I don't see any problem with that. I mean, it's definitely doable. But yeah, here again, I mean, you do have the same drawback as with the double drum system, where you have sort of these crevices in the combustion chamber. So emissions wise, this system will not be as good as poppet valves, and that is, yeah, I think a drawback of pretty much all the rotary valves. You would need to have like a rotary valve, like, so you need to have like the crankcase and the piston like inside of a rotary valve, so you have the rotary valve like circling around the engine, so that you have the radius like, instead of being in this direction, you would have the in this direction, so you have the cylinder underneath, so you would have like a rotary valve rotate basically around the engine. You could probably make some fun like test engine or something like that would actually could be able to make that work, like on a one cylinder or maybe like a X4 cylinder or something like that. But yeah, I think that would be more sort of a fun novelty item or something like that than like some serious engine, because yeah, you really want to be able to do like straight engines. You gain so much power to weight ratio from those types of engines that definitely want to do that. Okay, have you seen the open source free valve? Oh, that sounds interesting. Concept by Wesley Kagan. He tries to do similar systems at Koenigsegg in his garage. Oh, okay, that sounds really interesting. So yeah, we're doing rotary valves in this episode, but I could definitely want to check that out in future episodes. Yeah, to look at, yeah, if there's an open source free valve system, that is definitely interesting. So I mean, especially for like really, really high performance things that also need durability, if you can, in an engine like that, run poppet valves with like a free valve type system, so that you have free valve acceleration, free duration, like everything absolutely freely usable, then that is something that would be really beneficial. So you can run like extremely high horsepower engines on like hypercars or something like that, and still get really good durability. So you can still do like 200,000 kilometers on an engine, while still like putting out insane power levels and having like capability of going to really high RPM. Of course, if you stay at really high RPM, then you won't be able to do 200,000 kilometers, of course. But that is definitely interesting. But I don't want to get too much into that now, because yeah, this yeah, we're getting sort of a little bit off topic, but definitely a really good suggestion, and might do that for another episode. And yeah, it does look good. Okay, is there anything else? Free valve Miata running. That sounds interesting. Okay. Yeah, so we'll definitely probably want to look into this. And yeah, this actually does seem to be very beneficial, because yeah, I haven't heard of this at all. So yeah, very interesting that yeah, you guys send over links, and we can sort of look at that and think about things together. And yeah, so again, I mean, a disclaimer, so I haven't looked into all of this and crunched all the numbers and stuff like that. So these are just really sort of loose ideas and basically sort of rule of thumb stuff. But I would think that I'm reasonably good at those. So at least like designing things that I have some concept of. Usually I could just like ballpark something and it will be really close to optimal. Sometimes, of course, that's not the case, but in most cases, I mean, yeah, basic physics and stuff like this are like really similar. So just need some kind of a ballpark figure to be able to yeah, like get some kind of a baseline. Okay, like, is this more difficult or easier, or is this going to be like 10 times more difficult, or like 10% more difficult, and you can get really close really quickly with a lot of design stuff. So I do think that I should have some kind of a like reasonable view, but again, I mean, I haven't looked into this. So yeah, if people are claiming something and I'm saying something that doesn't correspond with that, then yeah, that doesn't necessarily mean that I think something is wrong or anything like that, because yeah, just potentially haven't looked into this, and there's just so many different things happening all over that. Yeah, it's not really possible to keep up to date on everything, but also very important to be able to, of course, really quickly like check, okay, this looks interesting and this doesn't look interesting, so that you can spend time on the interesting things. And if you're really good at doing sort of initial classifications of these and spending time on the interesting stuff, then you will get way ahead of the curve. So definitely something I would encourage. Let's just check these images here a little bit. Rotary valves seem interesting, but do they suffer similar issues as rotary apex seals? Rob Dude, you will need to go back and check this stream a little bit earlier, so did go through that. So yeah, unfortunately don't want to stretch this video out too far by going through that again. Oh, it makes me kind of sad that, well, I mean, that only 18 people are viewing, but yeah, this is only the first test episode, so YouTube definitely like very heavily will influence this. So if we have 18 people now, I mean, you guys are commenting and interacting really nicely and giving good suggestions and really like on topic stuff and really good things. So we'll definitely probably, yeah, if we do another one with a new topic, then YouTube will probably show that to more people and see if we can get those in. Of course, if YouTube is capable of showing this to people that are interested in engine tech is always a different thing, because yeah, doing that with AI algorithms is really difficult. So yeah, YouTube doesn't necessarily know how to promote everything absolutely perfectly. But yeah, thanks for the kind words, Robin, anyway. So yeah, hugely appreciated. And I think this is, I mean, really good. I mean, having, yeah, good conversations, people sending stuff to look at that are really on topic and good things. So yeah, really beneficial. And based on this, I think we'll definitely be doing another episode. We'll see if that will be next weekend, or if we can like do these maybe 2 times per week or something like that, because it doesn't really take a long time to do this, because it's a live stream. So just need a few minutes to set up and get all the intro graphics and do a thumbnail basically, and then we can just get going on it. So that is really good. Okay, but that's it for this episode on rotary valves. We'll probably be potentially looking into poppet valve tech and variable valve train stuff and poppet valves maybe, because yeah, especially if there's some new interesting stuff with some open source free valve things, then definitely really interesting and very yeah. And wait, who was that? So let's just get the credit going here correctly. Yeah, the Porakulho. Oh no, wait, the Soppakulho. Okay, yeah, so this is a Finnish guy apparently. Nice. So yeah, thanks so much for that info. I mean, I hadn't heard about that previously, so we'll be looking at that. Okay, but I'll kick out the graphics here, and we'll end this stream here. So can we get this going? Okay, so background video and stream ending. Nice, I got this. Okay, bye guys.